Test corrections, here we go. How do you do problem number one? Well, you gotta carefully distribute the -3 through, and it becomes -6y. And this was a plus sign. It's not super neat how it came out in the scan there, so I'm gonna put a little plus there, okay? And that becomes -3, and then we've got -4y minus 5 on the other side. So we start trying to get all the y's on one side, the constants on the other side. One way of doing that would be to add 6y to both sides, to add 5 to both sides. And you can see that these guys are going to go to 0. -5 plus 5 is 0. And this is 2y. And on the other side, those go to 0. That's why we added 6y to both sides, and we get a 2. And then we divide both sides by 2. So I'm going to take 2y divided by 2. 2 divided by 2, and I get y equals 1. So if you see a 6 out to the side on any problem, that means I couldn't find anything wrong with your work. That's 100% on that particular problem. If you see a 5, I know some people took 2 divided by 2 and they put down 2 and different things. So if I could find your work and I could find a small little arithmetic mistake, but it looked like you're going the right direction, you probably have a 5 out there if you didn't get a 1 right here, y equals 1. All right, next one. I would add 3n to both sides. So if I add 3n to both sides, I end up with 10n on the right side, and I have 24 over here. Then I'm going to divide both sides by 10. So I get 10n divided by 10, and 24 divided by 10, that comes out to be 2.4 is greater than n, or n is less than 2.4. So that would be another 6-point score out to the side. On problem number 3, let's see, problem number 3. First, you got to isolate this guy right here. Don't distribute the -2 through. No. Okay? Because it'll kind of mess the problem up. So we want to subtract 13 from both sides, and I end up with -4. I've got -2, absolute value of 2y minus 7. Now I'm going to divide by -2 on both sides. Dividing by -2 is going to get this to 1, so I get absolute value of 2y minus 7 equals 2. Then I break it into two cases. 2y minus 7 equals 2. 2y minus 7 equals -2. Then we're going to add 7 to both sides. We get 2y equals 9. Now I'm going to kind of shortcut some work here because this is getting fairly lengthy, isn't it? Then we're going to divide by 2 on both sides, and we get 2.5. Divide by 2 on both sides, and we get 4.5. Those are our two answers. We need to check them back in our original problem. So if I go -2, absolute value 2 times 4.5 minus 7 plus 13, does it equal 9? Well, this is 9. 9 minus 2, or 9 minus 7 is 2. 2 times 2, that's positive 2. 2 times -2 is -4. -4 plus 13 equals 9. Check mark, that one worked. -2, absolute value 2 times 2.5. Does 2.5 work? Right? Did we just come up with an extraneous solution? That's what we're testing out. So that gives us 5. 5 minus 7 is -2. -2 absolute value is positive 2. Positive 2 times -2 gives me -4. -4 plus 13, yes, that equals 9. Check mark. So both of these are my answers. I don't have to eliminate one of them. And we're moving on. It says write the equation in slope-intercept form. So that means I need to get it into y equals mx plus b format. So I'm going to start by subtracting 14x from both sides. So subtract 14x from both sides. Those aren't like terms on the right side, so I write down -14x plus 28. 28, come on, Nelson, 28. And then we got -7y on this side. Now I'm going to divide everything by -7. So -14x divided by -7. 28 divided by -7, that gives me 2x minus 4. This is my slope, the 2. 2 is my slope. Negative 4 is my y-intercept. Don't put an x right here because it's only the 2, the coefficient of the x, that's the slope. All right? On number 5, 5, you needed to use the point slope form of the line. Y minus y sub 1 equals m times x minus x sub 1. You got to take the 5, put it in for y sub 1. You got to take the 4/5 and put it in for the slope. So I go 4/5. And then I go x minus, and I put the 10 in for the x sub 1. And I'm done. That's it, full credit. Oh, shoot, I forgot to put my 6 here, my 6 up here. All these are 6 points here, each one of the problems, right? And this guy back here is a 6. And now let's see, let's get over to problem number 6. Here we go. Man, it seems like if we just added the two equations together, I'm going to add the two equations together, the y's are going to eliminate. So I end up with negative 4x equals 8, x equals negative 2 after I divide both sides by negative 4. Then I'm going to take my negative 2 and I'm going to plug it into the second equation. The opposite of negative 2, I'm taking the negative 2 and I'm plugging it in right there, okay? So the opposite of negative 2 plus y equals 6. That's positive 2 plus y equals 6. Y has to be 4, right? Because 4 plus 2 would give me 6. So let's go back to up 4 spots. Boom. That's where the two lines need to intersect right there. Negative 2 comma 4 is the solution to my system. Now, I'm not going to use that point to graph my lines just because maybe that point's wrong. I know I did on the practice test. I'm like, hey, we're running out of time. I'm going to use that point. But here's what I'm going to do. I'm going to stick a 0 right there. If I stick a 0 right here, this whole thing is gone. I get negative y equals 2, so that means y equals negative 2. I'm going to write a negative 2 there once I undo that big old 0 there. So that's negative 2 right there. If I stick 0 in for y, now I've got negative 3x equals 2, so if I divide both sides by negative 3, I'm going to put a negative 2/3 right here once I hit the undo button. Okay, so negative 2/3. So here we go. I go negative 2/3 would be like maybe about right here, and negative 2 is like right down there. Do you see how the equation is going to go right through that point right up there? Okay, so I'm feeling good about this so far. There's equation number 1 graphed. Here comes equation number 2 graphed. I'm going to make another little xy chart. If I stick 0 in for x, y equals 6. If I stick a 0 in for y, x equals negative 6. So I go over to negative 6. I go up to positive 6. Oh, look at this. Perfect. Boom. Goes right through the point that we thought it should go through and intersects right there, right? The next one, number 7, solve the system of inequalities. Okay, so let's see. First thing we got to do is treat them like equations. 2x plus y equals 4, and I'm going to graph that. So if I make another little table, x, y, I put a 0 in for x, I get y equals 4, right? If I stick a 0 in for y, I get x equals 2. So let's graph that. Those 2 points. So here's one of my lines. Should be a solid line, right? Because it's a greater than or equal to over there. Okay, so then I test out my special point, the origin. 0, 0 is 0 greater than or equal to 4? No. So I'm going to shade in this direction, shade in that direction. All right. So I test it out, test the origin out, 0, 0, and I get 2 times 0 plus, that should be an x right there, right? No. Yes, that should be an x. What am I doing here? 2x plus y. I had a y there. So 2 times 0 plus 0, is it greater than or equal to 4? This is what I was saying a second ago out loud, but I just wanted to write it down. That's a false statement. So I don't want to shade the origin in. I want to shade away from my origin. All right, now next problem, next line, put a little chart down, x, y, put a 0 there. I get negative 2. I put a 0 in for y, I get positive 1. So if I go to 1, 0, and I go to negative 2, 0, negative 2, that's my y-intercept. Now I'm going to connect them together. Oh, dashed line. Woo, dashed line. Oh my goodness. Almost messed that up. Dashed line. And then I'm going to test out the origin. So here we go. What if I test out 0, 0 in there? I get 0 greater than 2. That is a false statement. So I want to shade away from the origin. So I'm going to shade, let's see, I'm going to do it in red this time. So I'm going to shade down like this. Shading, okay? So this is my feasible region right in here. This is the solution. This is my solution right here, okay? Number 8, here we go on number 8. Let's see, find the maximum and minimum values. This is where you want to make a table. So my table is going to look like this. I put down my table, and the only points I need to test out are these 3 points. So I put them into my table, 3, 2, 1, -2, and -5, -2. Now, what am I going to test them out in? I'm going to test them out in this equation. So I put that equation right over here, 3x minus y. See, we want to know this equation, does it generate a minimum or a maximum at one of these points right over here? We're trying to identify which one's which. So 3 times 3 minus 2, that's 9 minus 2 is 7. Let's try it on this one. I stick a 1 in for x, I get 3 times 1 minus a -2, so I get 3 plus 2, that's 5. All right, next one. I go 3 times -5 minus a -2, that's -15 plus 2, that's 13. So, negative, excuse me. This is my minimum value, and this is my maximum value. That's all we have to do on problem number 8. Thanks for watching my video. I hope that makes sense. I hope I'm making that clear. If I'm not making it clear, call me over. I'll help you out.